Hey everybody, Newland here. Let's talk about how IRSA can be used to make three color images using visible and infrared data. First thing you need to do is go to the Finder Chart homepage and search for an object. So I'm going to search for the bubble nebula, and under arc seconds, I'm going to make it, let's say 1200. Notice if you pull that menu down and go to arc minutes, it's automatically converting for you. I'm going to choose large, and I'm going to turn off SDSS, 2mass, and Akari. I'm just going to keep digitized sky survey, the WISE all sky survey, or data from the WISE satellite, and from Spitzer Space Telescope. I'm not going to bother searching for targets in the field because I'm not necessarily doing anything other than making a pretty space picture. So I'm going to hit no. And then under image search options, I want to point out that you can see the images that are returned to you. So DSS1 is blue, DSS1 blue and red, and DSS2 blue and red, and then DSS2 infrared. And for the WISE survey, it's W1, W2, W3, W4. Notice that it's shorter to longer. That's how all of these go. So the first one would be blue, the last one would be red. The first one here is shorter wavelength, so it's not blue because all of these are infrared and all of the ones from Spitzer are infrared. But the shorter wavelengths we're going to color blue, and the longer ones we're going to color red, and the one in the middle will color green. Notice they give you way more than three here. So I'm going to go ahead and hit search and let it return a bunch of results to me. Notice I'm in a pretty wide screen here, so it may not work quite as well for you as it does for me because I have an extra, pretty big monitor. The simplest thing to do now is to click the icon for the three color image, which is this button here. And if it's possible with the data that's provided for the algorithm to create a three color picture, it will not only do that, it'll do it for all of the surveys you've selected. So this top row, these are all of the images that were returned from the digitized sky survey, which is in the visible part of the spectrum. And you can see here's the algorithm's attempt to make an image for me. And notice that DSS2IR is the red one. The first one listed there will be red, the second one will be green, and the third one will be blue. So it's RGB. So the longest one is assigned red. Somewhere in the middle will be assigned green, and the shortest one is assigned blue. And that's true for all of these. Even though the bottom two rows are not invisible, they're in the infrared. And you'll notice that for the WISE data, the algorithm is choosing number 4 for the red color, number 2 for the green color, and number 1 for the blue color. These algorithms are outside of our control, and if we were using DS9 or Photoshop or GIMP, the GNU image manipulation program, then we could have more control. But this way, everything's running in the browser, and it's also not that bad. And for the Spitzer data, notice this is SEIP IRAC 1, IRAC 2, 3, 4, and then MIPS 24. You'll see that the three color image is made from IRAC 3, which is red, IRAC 2, which is green, IRAC 1, which is blue. So the first one listed is what the algorithm is choosing to color red. The second one is what the algorithm is choosing to color green. And the third one is what it's choosing to color blue. So I'm going to hit the show everything as a single panel button, and we're going to navigate our way through to the here, wait, faster if we do it this way. Click on our three color image and then click the button to show it just as a single panel. And then I'm going to hit this icon up here, this zoom the image so it fits within the frame. And this is the three color image from the digitized sky survey. Notice that it still says DSS2 IR, DSS1 red, and DSS1 blue. So it's still telling me what is my red, what is my green, and what is my blue, that it's the algorithm is choosing to color with it. Notice that the actual red filter here is being colored green. So this, if we had changed this into red and used something else for our green, we might have a different color. So I'm going to navigate to the next one here. This is from WISE, and you'll notice it's not quite as sharp as the one from Spitzer. Spitzer is a telescope with a higher resolution capability. And again, there's the red, the green, the blue, and then for this one, it's the red, the green, the blue. Remember, these last two images, this one from Spitzer and this one from Wise, these are all wavelengths the human eye can't see. So these algorithms are trying to make a three-color image out of data that is not actually visible to the human eye. So the ability to zoom in and out with these buttons can really help. Switching between the tiles and a single frame can help when navigating in between these. Whenever you're confused, you can always go back to this. And what I did to get there is I clicked this and then the single panel and then zoomed in, but I'm already zoomed in. You can change the uh, individual palette used here. That's what this icon does. And that doesn't have any impact on the three color image, but it will have an impact on how it displays the other images. You'll notice when I go back to tiles that there's no color information for these five because that's not really a thing. Oh, notice it dragged around in there. Let me recenter it. I think that's this button. Nope. Yes, this button, center. My fault. And if I choose a different palette, color palette, you can see that it changes all of these images, which are cool. That's a cool effect to have, but it's not affecting the three color image. So I'm going to go back to my three color image, go back to this button, and make sure I'm zoomed in. I am. And then I'm going to click, oh, you know what we should turn off? We're going to click on the image overlay button, and I'm going to turn off where it selects my target. It does, however, tell you the right ascension here and the declination there, and which equinox this one is based on. And if you want to copy and paste this, you can actually click the clipboard, click the icon of the clipboard, and it'll copy it for you. And so unchecking that little box gets rid of the little circle target symbol down there so that I can actually have my pretty space picture. Again, though, right ascension, declination. That's one of the things you need to keep up with. And again, there's the red, the green, and the blue if you're ever confused about that. And you can uncheck whether or not it displays it, but that gets rid of the entire image. So we can close the overlays button now, window, and back to our image. We got rid of the little circle with the target symbol in there. We're almost ready to post us to social media and be super popular and everyone's going to love us, which is exactly what you want to do. But you can control from this button next to the paint palette looking thing the color stretch, and there's many options. You can check this, select this box that says use Z-scale for bounds, which has a pretty profound impact on your image, depending on whether or not it is a bunch of stars, a galaxy with nebulosity, or something within the Milky Way. You can have quite an impact by checking and unchecking use Z-scale for bounds, and you have to do it for each one to see what effect it's going to have. And then let's do it for blue as well. And I'm going to go back to the red tab, and instead of linear, I'm going to pick square root, and then I'm going to hit refresh and see what effect that has. So for green, I'm going to choose the same one, square root, see what effect that has. And then I'm going to do the same thing for blue, almost selected the wrong thing, square root, and see what effect that has. So it makes this color stretch has a pretty big impact on how it looks. You can also uncheck each of the Z-scale bounds and try it with that particular stretch and see what impact it has. And instead of the square root, you can try one of the other ones there, like the power law gamma. I'm going to try that for red, green, and blue and hit refresh. And the goal here is to make something that is profound and it has like the intended impact you want it to have. So that one didn't seem to do much. Let's do log and hit refresh on blue and then log on green and then log on red. Again, you got to do each one at a time, and it doesn't seem to have much of an impact there either. So I'm gonna go ahead and close that. And when I'm ready, I can save this image as a PDF. I can prepare, download, and save it as a PNG. You can also do a screenshot of this image and post it to wherever you'd like to post it. Um, and I want you to do this for the DSS, which is the Digitized Sky Survey, for WISE, and don't forget for each one of these you're going to have to turn off that layer, the circle with the plus. And I want you to do it for Spitzer, and you can manipulate them all the exact same way. So I'm turning off that layer in terms of the image stretch, or you can try something else. Look at this log stretch to 99%. See what impact that has. And that does it on all of them simultaneously. Let's try log stretch -2 to whatever that said. Uh, yeah, sure. That looks great. Let's try this one instead. So you can see that they each have a profound impact. If you want the most control, you can go to color stretch, but here it does that on all of them simultaneously. Any of these. There's the Z scale, there's log. So let's do Z scale async or whatever that was called. Oh, um, the weird version of the sine function there. Well, that really made it dark. Let's go back to whatever this is. I don't know about that either. So, how about that? Ooh, what a crazy effect. So sit and play with it, make something pretty, post them. Don't forget to include the right ascension and declination, which, by the way, if I put my mouse here in the middle, you can see that the right here is the right ascension and declination information. Um, the color information is, again, red is the first one, green is the second one, blue is the third one. And you want to do this for Spitzer, for WISE, and for uh, the digitized sky survey. And there you go. That's how to make pretty space pictures.